photometer. I will go through the light ink and dark ink transitions. Then I will explain the linearization process, the global ink limit. We will speak about black separation method, so GCR. And finally, I will go through the profile options before generating the ICC file. Then we will speak about Cal patch management, so basically how to save a profile from Easy Media and how to export a profile to another workstation, for instance. And finally, we will speak about printer color configuration, and I will speak about color rendering and which rendering mode should be used depending on your application. So I hope everybody can hear me well. And after this training session, we will go through a question and answer session, which should last a maximum of 30 minutes. Okay, so let's start the training straight away. So first questions, why calibrating a media with the RIP software? So I think here an image worth 1,000 words, as you can see here. We have the first image on the left, which is showing print output using no linearization, no global ink limit, and no ICC file. So as you can see, the results is really messy. We have a huge over-inking issue there, and there is no color management at all. The second picture shows you the same one, but this time printed using a linearization and a global ink limit. But still no ICC has been used to print this picture. So that means now we have a control on the ink consumption, but still we do not have any control on the color. You can see that the color is not good. And the final example is using the complete calibration. So using linearization, global ink limit, and the ICC profile for color management. And finally, we achieve something which is compliant. So that will be the purpose of today's training, is how do we achieve such kind of results using Caldera software and Easy Media. So here is another illustration of what is going on if there is no ICC profile applied to your print process. So for instance, here I'm using incoming CMYK file, let's say, which is which comes with an ICC, an input ICC profile. And then we are opening this file with the RIP software, and we are printing it straight away with the printer. As you can see here, the colors are not good at all. Why? Simply because the printer is not characterized. That means we didn't create any ICC profile, so obviously the color translation is not done properly. So this is what we're going to do today, is to create this ICC file in order to characterize the current devices and to do a nice color translation from the input color profile to the output color profile, and finally to get something which is compliant. And other topic, very important, I would say, is that you should use one profile for one single working environment. As you can see here, the media patch, in other words, the ICC profile we will do with Caldera RIP, is actually containing different kind of file. We have transition files, so this is only used if you are working with a CMYK plus light ink printer. We have a linearization file plus global ink limits, and finally we have the ICC file, of course. So everything is embedded in this media patch. Okay. And when you are creating a media patch, actually you have to take care about different variables. We have printer variables. Okay, so I'm talking about here printer technology, type of ink, type of substrate, and temperature. For instance, when you are working with a solvent printer or latex printer, you know that temperature are very important because you have to heat a lot substrate in order to dry the inks properly. But we also have some RIP software variables, as you can see. Here I'm talking about screening. So the type of screening you will use, the type of resolution, and the ink density, of course. So this will be set up during the calibration process, and the quality, for instance. And finally, we have environment variables, which is very important also. Here I'm talking about hydrometry, moisture, local temperature, etc. So if one of these variables may change, that means you will need to create a brand new ICC profile in order to ensure color consistency. So in today's training, I will create a profile which is based on specific variables. One thing also I would like to speak with you before going through the calibration process is the LAB system. This is something I will speak a lot during this training. I'm just going to give you a quick reminder about what is the LAB system. So the LAB color space is a method of color description which is hardware independent. So that means the LAB space contains all the human visible colors, and it describes those colors based on the standard observer. So that means if I'm using, for instance, a spectrophotometer, and I just want to measure a specific spot on this apple, I will get back some LAB value from my rig software, and this is the absolute color value from this specific spot. So it's very important to use this color space, which is neutral and absolute, in order to describe in an absolute way the color that we will measure with the spectrophotometer. So as you can see, this is a three-dimensional color space. We have the L-axis here, which is running from 0 to 100, 0 being the perfect black and 100 being the perfect white. Then we have two other axes. We have the A-axis, so this is red to green colors, and we have the B-axis, which is for blue to yellow colors. And as you can see, we will get back here some coordinates that will describe absolutely one specific colors. So here I'm going to speak about ICC profiles and profile connection space, just to show you how the rig software is working when it comes to color translation. So here I'm working with an input CMYK file, which is coming from Photoshop, for instance. If I open this file in a preview in Caldera software, I can spot a specific location, and I can get some information about the color on one specific spot. Sorry. Then we will use the image profile, okay, which is embedded in the incoming file. So it could be a photograph 39 or whatever profile you would like to work with. So this I'm going to speak a little bit later on. But this image profile will be used by the rig software in order to translate properly this actual color to the output color space, so the color space of the printer. So we can see that in the middle we have what we call the profile connection space, which is based on the LAB color system, obviously. So it will be very easy for the rig software to translate incoming LAB value, which are in the incoming ICC file, to output LAB value, which has been computed from the output ICC profile. So thanks to this profile connection space, we are able to translate properly one color space to the other one. And as you can see here, the real color value that will be printed by the software, by the printer, will be obviously different than the input value, because we are using color management, and there is an adaptation, and there is a translation of input value to output value. So that's the whole idea, and this is how basically the software is working when it comes to ICC profiles. So in today's training, we will only take care of this printer profile, so in other words, to the output ICC profile. So how to calibrate a media with Caldera rig software? We will use the dedicated software, which is Easy Media, and we will go through different steps. So I like to split the whole process into three main categories, I would say. We have the very first step, which is calibration. And during calibration, we only speak about inks and liquids. We are not talking about colors, okay? So the first step will be transitions. If you are working with light inks, of course. If not, you will start straight away with the linearization target instead. But in today's training, I will show you how to calibrate a printer using light inks. So that will be the very first step of the calibration process. So then it will be here global ink limits after linearization. So we will decide how much ink we would like to allow to be printed on the substrate. So this will depend, of course, on the type of substrate you are using. So it could be paper, PVC, vinyl, whatsoever. So depending on the paper, we will be able to push more or less liquids or more or less inks, obviously. And then after this calibration step, which is really important, we will get the characterization. And during characterization, we will speak about colors actually, because we're going to print an ICC target, which will be made of several CMYK patches. And then we will measure these patches with the spectrophotometers once again, and it will get back LAB value from what we did print. So we'll be able to do a relationship between CMYK value, printed CMYK value, and real color measured by the spectrophotometers in LAB value. So that's the principle of the ICC target. After this we will go through the ICC calculation. So we will set up the GCR, and so the gray color replacement. Of course, I'm going to detail everything during this training. And finally, we'll be able to create the ICC file that will be used into our media patch. Okay, that will be able to export later on for another printer or another workstation if needed. Okay, so that's what's for the small introduction. So now I'm going to switch to my rig software, and I'm going to open Easy Media to go through all the steps of calibration. So you will find Easy Media in your application bar in the main tab. Simply double click to open the module. And here I'm going to click on the printer in the middle in order to open the list of printer I'm currently using on my rig software. But if I click previous here, I can see also a branch icon, which is quite interesting. So if you click on it, you have this small checkbox, which is export all ICC profiles automatically. So what does it do? Actually, you will, by default, you will export the .icc file at the end of the calibration in one specific folder. Why? Because I think it's more convenient for you to retrieve those ICC files, especially if you want to use them in your PAO software, such as Illustrator or Photoshop, in order to do some soft proofing, for instance, or to simulate the output. This is what I do usually. I prefer to export everything, all the ICC file in one specific folder. So you can choose here where you would like to export them. So here maybe I can create a brand new folder on my desktop, and I can name it ICC file. And that's it. Then I will click again on my printer, and in today's training we will use this printer because I have already a bunch of different profiles I did with, and I will be able to show you different kind of examples. So then you can click next. Here you can see all the profiles that are being already done with this printer. For instance, if I click on this project, we can see that we have two current projects in this media. We have one made with a specific resolution and another one with another resolution, as you can see. So you can create a new one in this project, or you can go back to create a brand new media. So this is what I'm going to do. I'm going to go previous, and I will create a brand new media. So let's click new. Here is where you can name your current project or media. So of course, as you probably know, when we are creating ICC profile, as I told you before, we really want to calibrate printer with a specific substrate. So usually we give the calibration the name of the substrate. So here would be, for instance, PVC banner. Okay. You can here push a cost per square meter if needed, in order to get some prediction about the cost. Okay, let's put 5, for instance. And here the parameters and the comments. This will depend on the printer you are using. This is specific parameters for the Epson printer I'm currently calibrating. But if you are using Mimaki, HP, or whatever other brand of printer, maybe you will get other options. So I won't speak that much about it. So simply push the name and click OK. Then Caldera is asking you the password in order to validate, because now you are modifying the driver, because you are pushing actually a new media calibration. And here, as you can see, still I have 0 projects. So it's time to click next and to create a project for this media. So a project is actually linked to a mod. Okay, so here we go for CMYK plus light inks and a resolution. Like this, for instance. Here the parameters and the comments are the same I had in the previous window. Let's click OK to validate, and finally we can click next. And this will bring us to the calibration result. So we will do the calibration step by step. Just going to enlarge it a little bit. Let's put it like this. Okay. Okay, so as you can see here, my project is totally empty. I have no transition curves, I have no linearization, and no ICC profile. So once again, transition curves are only necessary when you create a calibration for a printer using light inks. If you do the same calibration with a printer without light inks, you will start straight away with the linearization. You won't see any transition options here. So I can click next to reach the first step, which is transitions. So before going any further, let's have a quick reminder about what is the transition. So the ink transition is required when calibrating a printer using light inks, as I told you. And here's the principle of the light inks. So why are we using light inks in wide format printer? Here is an example of 50% value of black, okay, printed without light inks, using only the dark black ink, as you can see. So to create this 50% coverage, the rig software will use a kind of after effect, okay, so it will print sparse ink dots, and this will give you something which is quite grainy. Of course, it will depend on the resolution of the printer, okay? But if you have a very low resolution, you will see a very grainy effect. And here's the same, but using now light inks. So the principle of the light inks is to be able to saturate the area and to get a kind of continuous tone effect. So if you squint your eyes, you should not see any difference between the two samples, okay? Because they are theoretically exactly the same spectral density value, but visually you will get something which is way smoother and just better looking using light inks. So light inks are not there to enlarge the color space of the printer. It is only here to improve the quality of the print, especially for skin tones and light colors. Here is another example. In the left, we have a picture that has been printed using a CMYK ink set. Okay, so no light inks. And in the right, we have the exact same pictures, but printed with a CMYK plus light inks. And here you can see that comparing both images, you can see we have a much less grainy effect on the right than on the left. So that's all about light inks, just getting a better visual resolution and smoother gradients. Okay, let's go back to the Riff software. So to create transitions, you will just click the next button. Okay, so I'm going to run the wizard, so that means I will print targets, I will measure targets, and I will build the transition curve. I click next, and here I have the choice between different transition targets. So for this training, I will use the X-Rite i1 Pro 2, because I think this is still the most common spectrophotometer in the market. But of course, if you guys are working with other spectrophotometers, you can switch to all these devices. Then you have to choose the light inks target. So be sure to use the same target for both light inks and dark inks. Okay. So I really encourage you to use the calibration target exponential 21 step. Why exponential? I will explain you later on when I will speak about linearization. But exponentials will give you just better results and better gradients at the end. And here make sure to use exactly the same target for the dark ink target as well. So here I'm going to print and measure the target. So I can click next. I can print the first one. I can click next, and I can print the second one. So here I'm not connected to any printer. Okay. So what I will do actually, I will come back and just open what I did measured with my spectrophotometer. Okay. So the next step for you will be to click next after printing both targets. And here you can, as you can see, you can start the measurement with the spectrophotometer. Here you can see your devices. If you want to switch to another devices at this step, it is still possible here by clicking the list. And very important, you have first to set up the device properly for the kind of media you would like to measure. So I will click setup. And here I have different options for this X-Rite i1 Pro 2. If you are using a Barbary spectrophotometer, then you will get other options, but this is more or less the same principle. Here, the reading mode has to be set in spectrophotometers always, okay? Because you are using a spectrophotometer and you would like to measure wavelength, okay? You would like to measure data in nanometers, okay? That will be translated by the RIP in LED value. So always use spectrophotometers, and in measure mode, always use spectral instead of LED, okay? You better work with spectral, and then the RIP software will automatically translate this value into LED value if needed. So just keep the default settings. Then here with X-Rite, we have an option which is enable double reading. So that means you will actually read 2 times each stripes. Okay, we have 4 stripes per target, so that means you will do 8 measurements. So why doing so? I will suggest you to do so when you are using very low resolution and paper with or substrates which are very textured, because you can have some missing reading or reading issue. So it will be better to enable the double reading to make sure to not have something which is bad. And the accuracy depends once again on the type of media you are using. If you are really struggling by getting the 2 same measurements, you will have always like error message. Then you can try to decrease the accuracy to medium or to low. Okay. Then this is the type of paper or substrate that you are calibrating. Okay, this will help the spectrophotometer to adapt to the kind of application. So if you are using photo paper, vinyl, or other coated substrates, I will suggest you to keep smooth. And if you are running a banner or very textured substrate, you can go for grainy or even very grainy. Then the scanning speed usually are used fast, but if you have some difficulties, maybe you can decrease it and put it to slow. And then we have another settings which is quite common these days when purchasing the latest version of spectrophotometers. You will have new measurement conditions, which are M0, M1, or M2. So let's have a quick explanation about what is M0, M1, or M2. So this is all related to optical brighteners or OBA. These are components which are added to the substrate to make the paper looking whiter than white. Okay, this is usually used in cheap paper just in order to make them more white and more pleasant. So the issue is that the OBA are very sensitive to UV wavelengths. Okay, this is the principle of fluorescence. That means if you are using something which is actually yellowish with optical brighteners in it, if the sunlight, if I'm using the sunlight or any other light with UV, then I will see kind of a blue light instead, and this will make the paper just whiter. And this could be an issue for some colors, because you will change actually the color of the document because of this optical brightness. So because of that, we are now using new measurement rules, I would say, which are the M0, M1, or M2. And here, as you can see, there is a very nice example. Here is a sheet of paper without any OBA, as you can see, without UV or with UV, there is not that much difference. And in the second example, this is a piece of polyester fabric, and we can see that this one is full of optical brightness, because when I'm turning the UV, I can see the fluorescent effect, and that's not good for the printing. And this is another example with using this sample. You can see that there is no gap in the wavelength. There is nothing really special to see. And if we switch to the polyester fabric, we can see here that we have a huge peak in the blue area, especially when you are using here the M0 and the M1 mode, as you can see. Why? Because M1 is actually using UV. So when you activate M1, okay, or if the M1 is available for this spectrophotometer, that means you will read the color with a light that is really close to the sunlight, which include UV light. And this will actually excite a lot of optical brightness, and it will give you a more precise color description of what you are going to measure. But basically, how to choose which measurement conditions, it's quite easy. If you know if you are using a paper which is normalized M1, then be sure to use M1 if available. If you are not sure about the paper, you don't know if there is OBA or not in it, you can use the M0 mode, which is the very basic and the default mode, I would say. The M2 is only for very specific cases. For instance, if you know that you will print for a very specific environment, like a museum or hospital, you know, where there is not that much UV in the light, and you won't have any issue regarding optical brightness. But usually this is almost non-used. Usually you will choose between M0 or M1, and if you are not sure, go for M0. Then we can click OK to validate. So the spectrophotometer is finally set up, and we can start the measurement. So here it won't work because I am not connected to any spectrophotometer. So I will just go previous, and I will load I will work with a profile that I already did. Okay. So this is the profile I would like to show you. Okay, I will go to transitions, create new transitions, and here you can see I can load existing measurement file because I already did the transition for this profile. And automatically it will retrieve the PPI, sorry, which is the transition file for this current project. So if I click next, and next another time for the dark targets, we have finally the result. So this is the screen you will get after measuring both light ink and dark ink targets. So this is the transition assistant. So here there is not that much things to say about. Maybe here just let's have a small recap. So you can see here a graph, okay, two-dimensional graph. And we have two axis graph, and we have the vertical axis, which is actually the ink density. So this is spectral density in percentages. In the horizontal axis, we have ink percentages, ink quantity, sorry, in percentages as well. So the maximum ink percentages is called Pmax, and the maximum spectral density is called Dmax. And all the points that you can see on the curve is actually the patches that you did measure from your target. So if you did print a target with 21 patches, which is usually the case, you will see 21 points, which are the reference points you did measure. So this is exactly what we get here, as you can see. So here it's a little bit more complex because we have more curves, obviously, because we have light inks and dark inks. So if I click next, I will see now the dark inks. If I click previous, I will go back to light inks. And obviously we can see that we have a huge difference of density between light inks and dark inks. We can see that dark inks are way higher than light inks. That's absolutely normal because light inks will be used in the very light area of the print. So in this step, there is not that much to do. Here you can see that Caldera is pushing auto limitation. Okay, this is the vector that you can see here on the bottom, and we can see that all the dark inks have been clipped at 95% by default. Okay, why not 100%? It's just for us to have extra margin for linearization later on. But yeah, this is the maximum Dmax by default. And in regards of this Dmax for dark ink, it will set up automatic limit for light inks as well. And as you can see, this is different value here. So this is all decided by the software automatically. So at this step, I don't do anything. Okay, I just click next, and what is really important here is the transition curve. So this is what we're going to tweak a little bit today. So let's go back to the presentation, and here is the transition graph I'm showing you right now. This one only focus on the cyan, as you can see. Okay, so there is different things to consider at this step. So first we have a ratio point here, as you can see. This is the point here at the beginning of each curve. So this point is set by default by EaseMedia when comparing this spectral information. So you don't have to touch anything here. So just leave the point as it is. Then we have two different points that we can play with. We have the dark ink introduction, as you can see, and we have the light ink stop. So this is why it is called transition. Why? Because we will start the gradient by printing only light cyan, and once we do not have any density anymore, any longer, we will introduce the dark ink, as you can see here. So from this value, which is around 20% to 75%, you will print actually a mix of light cyan and dark cyan. And at the end, because the light cyan is no more needed, so we will stop it and we will print only dark cyan. But the issue is that his media by default is pushing too much light inks, and this can be an issue later on regarding over-inking. Okay, you may have too much ink after during linearization and ink limit, and you will get for sure over-inking issue, especially with aqua-based printer, latex, and solvent printer. So here, the first task will be to decrease the light inks. So to do so, once again, I'm just going to play with this button and this button. But how to decrease, and how do I know which quantity of light inks I really need? This I will answer by showing you this example. So I've just focused here on the cyan, as you can see here, but it will be the same principle for light magenta and light black, of course. So here, what I suggest you to do is to take a look to the target you did print previously, the dark target, and then you will spot the patches where you can see grainy effect. So in this situation, we can see clear that from 0 up to 27 or 32%, we can see a grainy effect. Why? Because this is only dark inks which is printed on the substrate. So we already know that we will push light inks only on this area. And we know that pushing light inks after this value is just useless because we don't need to fill some gap and some gap with light inks in order to get a nice ink coverage, because here we have enough ink to get something without any grainy effect. And if you take a look to the light target alone, you can see, of course, that no visible graininess is visible, even in the very low density. This is the principle of light inks. So now we know that we will push light inks only from 0 to about, let's say, 30 to 38% for this example. And if I go back to my graph and I isolate the cyan, we can see that we are using way too much light inks here. So this will bring us over-inking issue for sure. So now I can move the value by clicking just the point here and by dragging it along the curve up to the specific value I would like to. So you can do that, or you can also open the number here, and here you will do the light stop or cyan around 38%. For instance, here is obviously it's accordingly to what I see here in this example. In your case, depending on the resolution, it could be a little bit different, of course. This is only following this example here. So here I set up the light stop around 38, let's say 40%, and I come back to the graph and I can see now that the light stop is around 40%. But the issue here, as you can see, I have a very steepy curve, and that's not good because I will have a broken area in the gradient. I will see a very broken part of the gradient, so that's not good at all. So to prevent from this, we can move the dark ink introduction as well. So I can put it somewhere like this, okay? What you really want to do is to, okay, if I display everything back, you really want, if I put the magenta, you really want to keep such kind of nice transitions. Okay, the transition is nice, but you just want to put it earlier in order to avoid over-inking regarding light inks later on. Okay, so that's the idea. So usually I will do the same for magenta and black. They are more or less the same behavior when it comes to light inks, but once again, it's up to you. Just have to watch carefully the dark target, identify where the light inks is really needed, and then change the value using the number, for instance. Here we put, let's say, 42 for the magenta, come back to the graph, and then I can tweak it a little bit like this. And here I have my new transition curve. I will let the black like this, okay? Just an example for you guys. And obviously we can see that we already saved a lot of light inks, and this will definitely help us to get a nice linearization later on while avoiding any over-inking issue. So this was for transitions. Once it is set up, you can click next. Then Caldera is asking you if you want to test your settings by printing testing targets. So at this step, I do not suggest you to print anything. This is absolutely worthless. Why? Because actually there is no linearization, nothing is really applied. So what you will see is not really useful. So at this step, I prefer to skip directly to linearization, and we will print something after linearization. Okay, so here, as you can see, we just moved to the next step, which is linearization. At this step, I will create new linearization curve. Okay, and in my situation, because my profile is in editing mode, I can actually see what I did in the past. But in your case, if you are running a brand new calibration, you will choose create new linearization curve and run the wizard once again, print, measure, and build, just like before with transitions. Then you can click next. Once again, you will choose the correct targets. So here I will stick to the same device, and I will go for the calibration target, exponential 21 steps. Okay, so let me explain you why is exponential target. Quickly. Okay, so here if I choose regular calibration target 5% step, let's say, that means you will print a target, as you can see here in the preview, made of gradients with 5% step, as you can see. So 0, 5, 15, 20, 25, 30, and so on, up to 100%. If now I'm switching to the exponential target, you can see that it is exponential. We start with 0, 1, 2, 3, 4, 6, 8, 10, and as you can see at the end, we have huge gaps, so we have 85 and 100%. So why printing such kind of targets? Because usually when you will do the linearization, you will get a curve like this. You will see that your curve will saturate quite soon, as you can see here. At 50%, I already reached the maximum density I can get with my printer. And by using a regular target, I will lose a lot of points, because usually I will clip the inking at 50% because it doesn't make sense to keep all this ink after this limitation. So that means I will keep only few points in order to calculate my linearization. But if I switch for exponential targets, I will keep way more patches in the light and the medium density. And if I clip at the same location, I will keep the double the color information, and I will be able to build better gradient at the end and better linearization curve. So that's why I really encourage you to use exponential targets. Okay, better instead of regular targets, especially if you are using solvent printer and aqua-based printer that you know are saturated quite soon. So here, like before, I will print, then measure the target. So I can click next, I can click print, next, and measure. Here, something I didn't speak previously is the options that you get here. We have option about the loading, so in which roll or plate you would like to print the target. There's nothing really special to say about that. The scale, of course, has to be 100% each time, otherwise you will have difficulties to measure it with Spectre. And the special options, yes, you can choose to 4 different orientations regarding the target, and you can also repeat different targets all along the page if needed. So you will print basically several linearization targets at once. So that's quite nice if you want to measure several targets in order to get more accurate results. So here I will come back here, print the target, click next, and start the measurement once again. Normally here the device is still the same, and there is no changes to apply at this step. So you can click start. In my situation, once again, I will click reduce, and I will load an existing measurement file, which is here a PPC file for linearization. Okay, so this is the screen you will get right after measuring your linearization target. So what is linearization? You can see different curves, so one curve per channels basically. You can isolate each curve to have a better view. And like before in the transitions, everything is based on this graphic. So once again, we have here ink densities, and here we have a percentages of ink, so a quantity of ink from 0 to 100%. So the purpose of linearization will be first to set up ink limitation for each channel. So here, if I take the cyan, for instance, we can see that it is not linear at all. What we are looking for actually is to a curve which is straight like this. It's never the case with the majority of printers in the market. You will always have such kind of bad linearization. That's normal. So the purpose will be to first set up where you would like to clip the ink, where you think that it doesn't make sense to add more inks. So to do so, I really suggest you to watch your target. Okay, so if I take the previous dark target, this is more or less the same. I really encourage you to watch carefully where you can't see any growth of density. Okay, and here, obviously, by looking at this target, I can clearly see that after 53%, it doesn't make sense to keep all this ink. Okay, this is only over inking issue and waste of inking. So from this principle, I can already decide to clip the ink here or around 53%. If I come back here to the automatic mode, okay, so the default mode, we can see that Caldera is pushing auto limits, and this is quite high actually, because it will detect the spot where the curve reaches 99% density. So usually this is way too much. Okay, if you keep the default settings from Easy Media, especially with such kind of printer, you will go you will have a big overinking issue. So here in this situation, if I take back this example, I would say, okay, I would like to clip my cyan to 53%. And by doing so, I will save like 40% ink just by doing this. So this is quite a huge benefit. So it's up to you. You can drag the limit like this wherever you want, or you can type directly here the Pmax value, so the percentage of ink maximum you would like to keep for this printer. So here will be 53%. I do not have any other example here for the other colors, but I will push more or less the same settings for all the color. If I go for yellow, it's even worse. As you can see here, we have a huge saturation point, and here I would go maybe here 38%. That's okay. And finally, we have the black. The black is maybe easier to calibrate because usually you will have how to say, even by looking at the target. Okay, when you look at the target here, normally the black is really easy to spot where you want to clip the ink, because this is usually a neutral color. For the blue, it's a little bit different, and for the magenta as well, because sometimes it is getting cyan and then it is turning blue. As you can see here, we have cyan area and then we have a bluish area. So some customer technicians prefer to push the ink the maximum in order to enlarge the final color space of the printer, but in some cases it could bring you some over-inking issue. So here for the black, I will go somewhere here, let's say, I think this is a good compromise, 62. Okay, so here I end up with my new Pmax, so percentages maximum of ink. We have 53 for the cyan, we have 53 for the magenta, 38 for the yellow, and 62 for the black. Once again, this is only an example following this printer for this paper. It will really depend on what you see in the paper or on the substrate. You may have, of course, totally different settings here. This is just an example. And what is interesting, and this is what I just showed you before here, regarding this LED view, you can activate also here the hue. Okay, and click all, and then you can display all the channels within the LED color space. And this is exactly what we can see here for the cyan. We have a cyan hue at the beginning, and then we have a hue turn, and it's getting blue, as you can see here. The color is totally changing. This is the same for the magenta, and a little bit for the yellow, but not that much. The color here is quite stable, but here for cyan, we have a huge color shift. And this will depend on, of course, on the type of ink that you are using. In this situation, it could be useful to keep, as I told you, a little bit more after this point, because then you will enlarge the color gamut. You will be able to print very deep blue and more colors, basically. But of course, make sure to not push that much ink, otherwise you will have over-inking issue. What I suggest you is to try settings, go to the next step, and you will see by printing testing targets, you will see immediately if it's okay or not. But here, let's say I'm fine with these settings, we can click next, and then Caldera is computing for you the true linearization curve that will be applied to your next jobs to print. And as you can see here, these curves are the exact opposite to this curve, okay? In order to finally to compensate the bad linearization of the printer and to get at the end very linear gradients. So this is why we call this linearization, just to linearize the ink of your printers. So then you can click next, and you can, at this step, I really encourage you to print a testing target right now. So click yes, click next, and here you can choose different color charts in order to check if everything is fine regarding transitions and linearizations. So what I suggest you to print is basically the first one, which is the gradient test chart. Why? Because this one, as you can see, is made of gradients in a circular shape, and will be much easier for you to detect any broken part in the gradient using such kind of pattern. If you are using only linear gradients, it is way more difficult for you to detect if the linearization is okay or not. If there is an issue, you will see immediately here on the shapes, you will see a darker area or a lighter area. But what you would like to get at the end is something which is really smooth without any saturated area. So that's what you are looking for. Then, if everything is okay, printing this target and you can't see any issue, sorry, you can click OK, I'm satisfactory, and then you will skip to the next step. If not, you will get back to the editor and you can tweak a little bit the linearization by clipping maybe a little bit more the ink. So we are arriving to the last step, of the calibration, which is the ink limit. Then we will go through the profiling, which is all about colors. So the ink limit is very important because it will define how much ink the substrate is able to support. So this will set up your maximum quantity of ink to print at the same time for one specific output color. So to do so, we will set up a new ink limit, and once again we will run the wizard. So here it is said that you will print, measure and build, but this is actually wrong. You will just print and build. There is no measurement required for this step. You will only take a look to the target with your eyes, I would say. You won't measure it with any spectrophotometer. So click next and choose your ink limit target. So I'm always using this one, which is the dynamic target. Okay, this one is perfect. Why dynamic? Because actually it will take in consideration the Pmax that you did set previously. So if I come back to the previous step, okay, linearization, edit, check current linearization, I can go to numbers here and I can click 20 for instance. And this will show me back my Pmaxes. So here in this situation, I have 53 plus 53 plus 38 plus 62. So this will give me something like more or less 200%. Okay, so if I do the sum of the four value, this will give me about 200%. Okay, 200% out of 400% because theoretically I could push the ink at 400%, which is 4 times 100% for each ink, but obviously this is way too much. So here this will be 200%. And if I come back to my ink limit, the dynamic target will keep this 200% information in order to generate the target to print. So basically you will only print a value from, let's say, 90% maybe up to 200%. So you will only print up to here, because after it doesn't make sense to print more ink, because anyway with the current linearization, it won't be possible for you to print more ink than 200%. So that's why it is a dynamic target. So once you print this target, okay, so to print it, it's the same as before, okay, very easy, just choose the action to perform, the scale, and you will print it, and then you will set up the global ink limitations. So to do so, I'm going to show you a couple of examples of typical cases to avoid. So this is example based on linearization target and ink limit target, as you can see, but it's just to show you what you would like to avoid at this global ink limitation step. So here we have different bad examples using different printer technology. So here is more about UV printing. So you can see some gloss bending in the substrate. That means there is too much ink. Okay, the thickness of the ink is too high, and that's because maybe the linearization is too high as well. So you better go back to linearization and reduce a little bit the inking before reprinting the global ink limit target. Then we have matte effect. So as you can see here, we have a glossy ink, no problems, but at a specific point, we can see that it's going matte. And that simply means that the drying is not made properly because too much ink. So you don't want to see this on the final production, so you better decrease the Pmaxes. Then we have a 3D texture, so this is typically for UV printer, once again. Then we have drying issue, so this is typically for latex, solvent, and aqua-based printer. So if you can scratch and you can mark the global ink limit with the finger, so that means there is too much ink and this is not drying properly at the output of the printer. So definitely too much ink, so you have to clip the ink before it happens. Here the same with the bleeding. We have patch which are bleeding with each other, so that's not good. You better clip before it happens. Otherwise, we have cases where ink is going through the substrate. So that's not good at all. You definitely don't want to see this on the final production. So if this happens, be sure to clip the ink before, of course. So if I go back to my rig software and I open my dynamic target, basically what you will do after printing this target, you will look at the composite patches. This is only composite patches made of different value of CMYK, sorry. And as soon as you can see that there is a stripe which is not, which is bleeding or which is not dry, then you be sure to not keep it. So you will want to clip the ink before it happens. So this is simply as that. So in this situation, let's say I can see my first overinking issue at 170. So I will better clip at 160 just before it happens. So I can go back with the next story, and here I will type my maximum ink limit. Okay. Always preserve black ink. Okay, this is default settings. Do not use this. This is only old algorithm to which was working with very old profiles made with Caldera software. But always keep the preserve black ink. Then click next. You can also print testing target right now, and I really encourage you to do that. And at this step, I suggest you to print this target, which is the bleeding, not this one, sorry, not the bleeding target, but the overinking and bleeding test chart. So this one is quite nice because we have a very saturated color everywhere, and this will show you if you have overinking issue in very small details, as you can see here. And the other pattern here is also interesting because it will mix all the colors together. You have such kind of chroma pattern, and you will also be able to see where the black would be introduced depending on the color. And you can see for each one the pure value. So we have green, which is a mixture of 100% yellow plus 100% cyan. After linearization, of course, so in our case, it will be 53% plus 38%. Then we have pure yellow, so 38% yellow in our case. Then we have the red, which will be a maximum of magenta plus a maximum of yellow, sorry. Then we have the cyan, so pure cyan, so in our case will be 53% cyan from our linearization. Then we have pure magenta and pure blue, blue which is the maximum of cyan plus the maximum of magenta. Okay, so we will give you basically already a nice preview of the pure color that you will be able to print with the current linearization and global ink limit. If you can see any bleeding effect, especially here, where you will start to add the black to other colors, then definitely just leave it there, come back to the previous linearization or ink limit and try to reduce it a little bit in order to avoid any over-inking later on during the production. Then we can click next. Let's say we are satisfactory, and then we can go to the next step, which is the profile. So finally here we will speak about colors. Here you would like to create a brand new ICC profile using I1 V2, which is the color engine made from X-Rite. And you will want to run the wizard, which is print, measure, then build your calibration file, your ICC file. You can click next, and once again here you will choose which target you would like to print for this step. So once again here I'm dealing with the X-Rite I142, and here I will suggest you different targets depending on your applications. So usually what I like to print when it comes to X-Rite I142 is this one, which is quite a huge one because it's almost 2000 patches as you can see. But the good thing with this target is that all colors are scrumped, okay? They are not organized in gradients, they are all scrumped. So that means you will not have any reading issue with the spectrum photometers by measuring two colors which are very close to each other. Then, in the middle of each stripe, we have a separation, white and black separation. So this is quite nice when you are doing a textile application, because you'll be sure to have a nice separation between each patches. So this one would be the biggest one I will suggest you to print, and the minimum one I'll suggest you to print is this one, the 946 patches. This is the smallest one I will advise you. If you don't have time, we don't have any automatic spectrophotometer, and if you have time and you would like to have something maybe better, I would suggest you to go for this one. So then, after selecting your target, you can print and measure the target once again. So next, choose how you will print it. The scale has to be 100%, of course. Click print, click next, and click start to start measuring the target. So once again, in this situation, I'm going back and I'm going to load my existing measurement file. So after measurement, this will be the screen you will see. So here we already have some options regarding the profile itself. So we have the choice regarding the profile size. So we can choose between small, medium, or even large. So what is the difference? This is just a matter of interpolations. You know that when you measure such kind of targets, you have reference points. So these are the printed patches that you will measure with the spectrophotometers. But you can interpolate points in between, okay? Thanks to a specific algorithm, you can create in between colors in order to have a profile which is more complete and more precise. So the higher the profile size, as you can see here, small, medium, large, the more the color information in the profile, and the faster the reprocessing, because when you will translate input color information to the output, you will have already a lot of matching points, I would say, in the output ICC profile, and normally the repeat time will be slightly faster. But this is not a huge difference, of course. This is also in regard of if you want to share this profile by email, for instance, it won't be possible for you to send it because it will be more than 10 or 20 megabytes. Instead, whereas a small profile is a few kilooctets, so it will be faster to transfer by mail, for instance. But usually, I really like to go for a large one, especially if I did use a large target like I did for measuring the ICC profile. Then we have option regarding perceptual rendering. So I'm not talking about perceptual rendering right now. I will go through it a little bit later on. But just for you to know that if you tweak some value here, this will be used only if you are using the perceptual rendering at the output. Meaning if I open a printer and I would like to print this file, for instance, we can choose here in the output settings which rendering you would like to use. So if I choose perceptual here, that means I will actually use these settings in order to map my my color space. That's it. But if you are using colorimetric, for instance, this won't be used at all. Usually, I always keep the default setting for perceptual. If you want to know more about what is doing what, I highly suggest you to duplicate your profile. So I'm going to show you how to do it later on. So to duplicate your profile and by switching and testing all the value and see finally which one fits the best your needs. But in this situation, I will leave default. Then we have smoothness, accuracy, and balance. So this is all about your type of application. If you know that you will print a lot of spot colors and how to say solid colors, I will suggest you to go for more accuracy. If you better print photography and very a lot of gradients, etc., I will suggest you to go for more smoothness. This is just another way for Caldera RIP to translate colors from input to output, and depending on your setting, you will have better gradient or better color accuracy. So usually I push something in the middle, which is balanced, and that's fine. Then finally we have viewing conditions. You can switch from D50 and D55, for instance. So usually we say that D50 and 2 degrees observer is nice for daily print jobs, okay, for common and common tasks, I would say. And if you go for something which is more related to textile application, I suggest you to go for D65 and 10 degrees. But usually when it comes to wide format application, we use D50 and 2 degrees. That's okay. This is only it actually calculates the viewing conditions, so how the color will be translated, and it will be adapted depending on the viewing conditions. Here, for example, we can see that there is a huge difference between the different type of light. Okay, if I'm using a D50, which is 5000 Kelvin, this is kind of light which is daylight at midday. The D65, this is actually an overcast sky, so you will have light which is a little bit more bluish, I would say. So depending on where you're going to display the final print, you can choose how to adapt the color, but usually we use D50 and 2 degrees. Then we can click next and we arrive to the black separation method, which is really important. So here we'll talk about GCR, which is gray color replacement. As you can see here, we have different level of GCR. We have GCR 1, 2, 3, 4, no black, and max black. So of course, no black, I don't advise you to use it. Why? Because you won't print any black in your jobs. This is not advised. So you can switch between GCR 1 to 4 or max black. So first off, what is GCR? So GCR is known as a gray component replacement. So theoretically, we know that the black color can be obtained by mixing some 100% yellow plus 100% cyan and 100% magenta. So this will give you a perfect black in theory, but you know that it's never the case. You will get like a brownish and a gray color, which is not good at all. So that's why we add the black color in the print industry. And in the other end, by adding black, you will save a lot on cyan, magenta, and yellow. As you can see here, this is color separation without black. You can see that we have a lot of cyan, a lot of magenta, and a lot of yellow because we have a lot of gray area and black area. But if you add the black, you can see that we are using less cyan, less magenta, and less yellow. So this is what GCR is about. Basically, by replacing cyan, magenta, yellow components by black components. So here is a quick example using a sample. So here I have a color, output color, which is 80% cyan, 30% magenta, and 50% yellow. As you can see here, we can evaluate how to say a gray area from this color. Okay, so theoretically this is a gray area because we can take 20% cyan plus 20% magenta plus 20% yellow. That will give you theoretically gray. Okay, so this gray area can be replaced by only 20% of black, obviously. So this will help us to save on other color. And as you can see, if I compare the total ink coverage before GCR, we were at 160% ink coverage. Now we are at 120. So we just saved 40% of ink just by using a GCR. So that's the principle of GCR. Replacing gray components made by cyan, magenta, yellow by black only. And depending on the value of GCR, you will use more or less black. So usually the higher the GCR value, okay, the more the black you will print instead of C and Y components for especially for gray area. And the maximum black is a step forward, meaning that you will really print a lot of black instead of other colors. And we can see the levels here. By default, it is set as GCR2, which is in between settings, I would say, which is working with much applications. But for specific cases, I will suggest you to go for GCR4. Why? Because higher GCR will help you to get more gray neutrality, for instance. This one is a weak GCR, GCR1, let's say. We can see that we have something, I don't know if you can see it on your screen, but for my screen, it's really obvious. We can see magenta shift here. Why? Because the gray component is made of cyan, magenta, and yellow. Now I'm printing the exact same pictures, but using a strong GCR, so a GCR4 or a maximum black, for instance, and we can see that we have much more neutral results. And we can see that all colors have been decreased a lot, and we just increased a lot the black. And we did a huge ink saving as well here. So this is two extreme examples, but just for you to understand what are the consequences of the GCR. The other consequences of GCR is the black neutrality, of course, as I told you, but also the graininess. As you can see here, using a GCR1, I will use a lot of cyan, magenta, and yellow dots to create my gray gradient. Okay, so I will get very smooth gray gradient, but not so good gray neutrality. As you can see, I have something which is quite bluish here on the left. By using a strong GCR, you will replace once again a lot of these gray components CMY dots, you will replace them by black only. So you can see much more black dots. So usually you will see much more graininess. So you get something more neutral, but more with much more grain in it. So this is not the perfect settings if you really want to get really nice shades and nice gradients, I would say. But if you are looking for grain neutrality, I highly encourage you to go for high GCR. But in some application, we have a perfect settings here. Why? Because I'm using a printer which is including black light inks, as you can see here. So that means I don't really care about graininess issue because I know that I am using light inks. So anyway, in this situation, I can use a GCR4. I'm not so afraid because of my light inks that will prevent me from having that much grain in the final results. So my advice, if you are using CMYK printer and you really want to have grain neutrality, I suggest you to go at least for GCR4 or maximum black. If you are using CMYK printer including black light inks, I suggest you to go for GCR4 anyway. You will get the best of the two worlds. You will get nice gradients, and you won't have any graininess issue thanks to the light inks. So in my situation here, because I'm using light inks, I will go for GCR4. Then you can choose where you would like to start the black printing. Usually it's 20%, but if I'm using light inks, I can push maybe 0, because I know that even with a very low density, I won't see any graininess issue. Black start, I suggest you to keep 100% each time. Maximum ink, by default this is 350, but you can push 500 as long as you know that your ink limitation is okay. And the GCR amount will define which area of the gamut will be impacted by these GCR calculations. So here, for instance, I have two examples. We have a weak GCR amount, which is 10. Okay, let's say 10 here. So that means only the color very close to my neutral axis from my printer gamut will be impacted by the GCR. Okay, so only these colors will be maybe replaced by the GCR using more black. If I push the default setting, which is 75%, which is the setting I use usually, then as you can see, the area is much bigger. And that means all this color around this gray axis will be affected by the GCR. So yeah, it really depends on your needs and how much ink you would like to save and how much you would like the gray to be neutral. But usually 75% is a nice in between. This is a good setting. Then intelligent black, honestly, I don't really know what is doing. This is usually if you activate it and you can see a peppering effect on your print, like black dots in the yellow area. I will suggest you to recompute the profile by deactivating it. Okay. Usually I keep this deactivated. I don't see huge difference between prints using or not using intelligent black, but usually I prefer to let it deactivate it to avoid such kind of black dots issue in yellow area. Okay, so once the GCR has been set up, you can click next, and now we're going to calculate the ICC profile itself, as you can see. So this will take a few minutes. So it depends on the size of the profile itself and on your computer, of course. But here I will just cancel because I already did the profile, so I can go back to the main tab of profiling, and here I can edit and check the current profile. So after calculation, you will end up with this screen, okay, which is showing you some color analysis, I would say, and showing you basically the gamete and how big the profile is. So here we have first interesting information. So first the white point here. This one is quite interesting. This is actually the white point value, which is of course the substrate value. So the paper value, the vinyl value, whatever. In this situation, it was a glossy photo paper. So this is the paper white. We can see here, for instance, in the B axis of LID, so the blue axis, we have -8. So let's quickly on the LED space, what is the -8? Okay, so -8 will bring us to a very to a blue area, basically, as you can see here. And why? Because remember the M1, M0, and M2 measurement conditions. Here, I think I did measure a paper which contains a lot of optical partners, and I did use the M1. So I did use UV light to excite the optical partners. So that's why I have a fluorescence effect, and that's why I have this blue shift in the blue axis. But that's normal. If you are using a paper that doesn't contain any optical partners, like a banner or a vinyl, you will get something really close to 0 here. Then we have the black points. So this is the color, the darker color that you can print with your printer, with this paper and these resolutions. So as you can see, it's quite dark. It's almost 0. It's a 3.7. So if I take a look to my gamete here, I can play here with the lightness of my LED color space, and then we can see the size of the gamete. If needed, you can also display the gamete in 3 dimensions just by clicking the 3D, and then you can see the gamete in 3 dimensions. That's it. But here, yes, it's quite a nice gamete, of course, because I'm using a photo paper and I'm using Epson printer, which allow me to get really nice gamete even in CMYK mode. Just going to leave this. So what you are looking here is to get nice shapes, and you don't want to see any broken area. If there is broken area here in the gamete, that means maybe there is measurement and there is issues while measuring the ICC target. So if you can see too much of this broken area, I would suggest you to reprint or to at least to remeasure the ICC target. But here it looks nice. We have a color analysis. It's quite nice because we can have a prediction of how many of Pantone color I can print with this printer. So here's 85. So for CMYK profile, it's quite nice. Yes, and you have other information here. I'm not going to detail everything, but yes. What is quite nice also is that you can compare 2 gametes together. So we can compare this profile with another profile. So here I will take a standard profile, which is CMYK Photograph 39, just to see if I'm able to print the wall color profile. And here we can see that my gamete is way bigger, and I can print, I think, 100% of the Photograph 39. Maybe here a few colors that are missing, but it's very good. And if I go back to analysis, we can see here that I can actually print 100% of this Photograph 39. So that's fine. Of course, depending on the paper you are using and the printer, you may have totally different gametes. Okay, like UV printer will never give you that bigger gamete because this is different inks, different substrates, and this is once again just one example for you guys. Okay, I'm not going to speak about standard, it's more for specific training, but here is the full process when it comes to doing a calibration with easy media. Once you are okay with everything, you can go back to status and you can save the project. And that's it. And here, now if I go previous, I can see in the list that my project has been completed. And if I quit Easy Media, I should be able to see it in my printer. So here's my printer. Takes a little bit of time, and here's the list of profiles. So here my semi-gloss training profile. Here is red simply because I'm using the wrong color mode. Okay, I didn't do it with a CMYK plus orange and green color. It was only CMYK plus light, and I think the resolution is wrong. So yeah, now I'm using the good resolution, and everything's fine. Okay, so now I will speak a little bit about color configuration and Caldera software. So how to configure your software accordingly to the type of job you would like to print. So here, if I close my printer driver and I go back to my application bar, we have a special tab. If you click on it, you will reach the color configuration of the whole rig. So this is global color configuration for all the drivers, basically. And here we have interesting informations. First off, we can see that by default, we honor embedded profiles. So I really advise you to keep it activated because as I explained you earlier, you really want to translate incoming color information, which are in the incoming ICC profile, to the output ICC profile you did. So if you want to do so, you really need to honor embedded ICC profile. Then here, the three profiles that you can see here, they are only applied if the file is coming without a profile in it. Okay, this is default profile that will be applied to the incoming job to print if this incoming file is coming without input ICC profile. So here in this situation, this is the default setting by Caldera. It's quite okay. It's RGB, yes. Caldera CMYK. Maybe you prefer to switch for FrogBat 39 because this is what we are using a lot here in Europe. Yeah. Let's say this is by default ICC profile in the case the file is coming without. Then if I click OK, I will open this file, or I will open a new one just to show you what is going on. Go to the public folder, file to print, Caldera London, and here no files, okay. Okay, I will use this one. I'm just opening a PDF file just to show you how it behaves regarding the ICC profile. So if you want to get more information about what is inside the incoming file, you can take it and drop it on the info icon. Then from here, we can go in ICC tab. And here it's interesting. As you can see, the file is coming without any embedded profile. As you can see here, it says 0. And here in the profile, we can see that we have a coated FrogBat 39, which is applied by Caldera. And this is absolutely normal because this is what we said here in the color configuration. This is the default CMYK profile. If now I switch for, let's say, a swap, and I reopen the same file, you have to reopen it, of course. reopen it, I should see here in info, yeah, the swap ICC profile, since the file still doesn't contain any embedded ICC profile. Then if I do the same with a profile, with a file, sorry, that contains an ICC profile, let's say here,
Takže on ti akože ukazuje, ako by si to
mal to print, I would go for this one. Okay, drag and drop it in info, and we will see what is inside. Here we can see that there is an embedded ICC profile in this one, which is RGB Pro Photo, and here we can see that it has been well honored by Caldera software. We are using it as embedded ICC profile simply because if I go back here in color, we are honoring our embedded ICC profile. So this is the settings I really advise you to keep. Okay, PDFX output intent, it's only in regards of PDFX basically. Okay, so that means that PDFX usually contains output intent, which is for graph 39. So even if there is no embedded ICC profile, you have an output intent. So it will be loaded as the color profile by default. So it's up to you. Usually we keep it activated, but it's only if you are working with PDFX files. Okay. So that was for the global reconfiguration. So now if I go to my Stylus Pro, I can open a specific color configuration for this current printer. So I will simply drag and drop an image to print. Let's take this one. I'm going to the color settings. And here we can see that we have the swap which is activated because that's the default profile to apply if there is no profile coming with the file. So that's all good. In the output, we are activating the color management. Okay, so that means I am using the ICC file from the previous profile I did. I am using the curves and I am using my light inks transitions, of course. So everything is well activated. So make sure to well activate the color management, of course. And here we can see that we have different rendering intents. So I will finish the training with that by explaining you which one to use for each applications. So usually we like to work with perceptual because this is the most common one. Why? Because actually the perceptual rendering, let me show you, fits a lot of different applications. Okay, so why? Because it will actually compress the whole color space into the output color space. So for instance, if you are using in the input, like this file, you are using a Pro Photo RGB profile, so this is usually a huge color space, okay, because this is RGB color space. You better print this using perceptual for sure, because you know the printer profile that you're going to use is way smaller. And what happens with the perceptual is that you will compress the whole RGB color space, for instance, into the output CMYK color space. So that means you will keep the color differences between each colors. For instance, if these two colors are not inside my destination color space, I will remove them inside and I will keep the differences. But even the color that I can actually reproduce will be moved inside in order to keep the relativity between each colors. So you will have wrong colors if you prefer, but you will keep nice gradient and nice shades. So this is definitely the rendering intent you would like to use when you know that the incoming color space is way bigger than the color space of the printer. Then if I'm using a CMYK file, okay, which is using, for instance, the swap or forward 39 input ICC profile. Then in this situation, I can use perceptual, of course, but remember that I know that my current profile is able to print the whole Fogora 39, color space, I would say. Then I can maybe use the colorimetric. So what the colorimetric rendering does is actually every color that you can print and that are inside your printer gamut will stay in place. Okay, so that means you will have a one-to-one color rendering. You will have much more accuracy using colorimetric. Of course, if you know that the printer gamut is way smaller than the incoming color space, sure to use perceptual. I would say this is the most common one once again, but if you know that you can print everything from the incoming images, then choose colorimetric. You will have something which is more accurate. Then finally, we have also the black point compensation. So black point compensations is to use with the colorimetric rendering. You can add it to the colorimetric. So you will have colorimetric plus BPC for black point compensation. So what does it do? Actually, if you for some application, if you are using the colorimetric intent for photographic purposes, for instance, you may have such kind of issue. Meaning here at the input you have a nice color information, you have details here in very dark area of the picture, but after printing you can see that you will lose a lot of information and you will have a flattened area. So if this happens, maybe you can use the black point compensation to avoid it. Because rather than having such kind of, I would say, linearization for the black, you will have something that will smooth everything up. And this will help you to keep such kind of shades in very dark area. So just to show you the difference. So this is without the BPC, and now if I activate it, I will get back more details in the print. Then we have another one which is absolute saturation is very for exceptional purposes. Usually you don't use it, and absolute is only for soft proofing. Okay, I'm not going to speak that much about it because you are not going to use it in a daily basis. This is really to simulate what is in the input ICC profile onto your paper, basically. So it will even simulate the white of the incoming ICC profile. But usually you will use perceptual, colorimetric, or colorimetric BPC. Perceptual for photographic stuff, or when you know that the incoming color space is way bigger than your actual output color space. And colorimetric, if you know that you are able to reproduce all the range of color from the incoming image. And colorimetric BPC is the same while ensuring to get such kind of details in very dark area. This is all about the type of application you would like to do. And what is nice is that you can really target the applications you would like to treat with such kind of rendering. If you click Advanced, you can say, okay, for images, it would be better to use perceptual, but for vector shapes, maybe it's better to use colorimetric in order to get more vivid and more and stronger colors for solid colors and vectoral shapes, basically. So this is something you can set up from your driver itself. I really do recommend you to do it from the driver itself, better than doing by default from color configuration. Why? Because if you do it from here, it will be applied to all the printers, and maybe you prefer to have different settings for each printer and each applications. So what you can do is to create presets, for instance. So here I would like to print maybe vectorial shapes in colorimetric mode.
Áno, Caldera sa dá nastavať, že obrázky a vektory kvázi akože inak.
So we have perceptual here for images, so pixel images, and colorimetric for vectorial shapes.
Obrázok a vektor a
so what you can do here is to create a preset, like clicking this button, and here you know that it's used configuration
na obrázkovej časti.
Perceptual.
Je to fajn teoreticky, ale v praxi je to nepoužiteľné.
For instance. And then by selecting in the list, you'll be sure to switch your color configuration. As you can see here, if I switch to default, I will get back the default color configuration from here. And if I switch to my config, I will switch to what I set up previously. Okay, so I think that's all for today's training. It was a little bit longer than expected. I will now dedicate the next 30 minutes to answering questions I get from the chat module, if not already done. And if you guys still have some questions, do not hesitate to write them in the chat. It would be a pleasure for me to help you and to assist you.
Toto bol taký veľmi ťažký teoretický úvod. Akože toto väčšinou trvá akože tieto to je tak na jeden deň väčšinou, takže toto bolo hodne takého výkliku. Ale akože aspoň také nejaké základy tej teórie.